Hi folks, welcome back to Physics with Captain Rod. The purpose of this video is to introduce you to the concept of capacitance. Now what we're looking at here, right here, imagine some conducting surface, and right here is another conducting surface. And now imagine that we're going to hook these surfaces up to a battery here. So we actually take the lead. Now remember, batteries have a positive terminal and a negative terminal. So let's say, it's hard to see in my picture, let's say this is the positive terminal and we hook that up to here. Whoops. We hook this up to here, and negative terminal, we hook this up to here. And think about what the battery is going to do. Again, a battery basically is a charge pump. So if this is the negative terminal of the battery, it's going to push electrons onto this conductor, giving it an overall net negative charge. And that charge will be on the outer surface of the conductor. Right? This is the positive terminal of the battery. It will pull electrons, leaving the conductor with a positive charge. And that charge also will be on the outer surface. Now, the reason I kind of put these charges where I did, if this thing were all by itself, that charge would spread out uniformly over the surface. But it's not by itself. It's next to this conductor that's negatively charged. So this charge attracts one another, which means the charge configurations would be similar to the way I have them drawn. Now it's important to realize something now about the region and space between these conductors. Right? We have plus on the left, minus on the right. We're going to have electric fields now between these conductors. And if I were to draw some of the electric field lines, I'm going to go ahead and draw them in red. The electric field lines might look something like this. Now, whether I get them perfect or not is not, important for the discussion. There's kind of a rule that I'm using to draw these. If you'll notice, I'm making sure that the conductors, or the electric field lines, hit the conductors at right angles. It's important to realize that the electric field lines would point in this direction. And I might draw one more in here, there. Now, another very important thing to realize, we now have a potential difference between these conductors. And remember, potential difference is basically field strength times distance. Now, I'm not implying that the electric field would, in the picture I have drawn, would be perfectly constant, but that's not important for the discussion. Also notice that what we have now is a charge imbalance. Right? We've got a charge on this conductor on the left that I'm going to call plus Q. And we're going to have a charge over on the right that I'm going to call minus Q. Now, another important thing about this system is to notice that as far as this is concerned, the net charge is zero. There's no net charge on that system. But you notice that what we have is a charge imbalance. So this system now has a charge imbalance, plus Q on the left, minus Q on the right. And we would just say that the system is charged to an amount Q. Now, the Q, the amount here, is going to be a function of several things. One, it's going to be a function of the voltage of the battery, the delta V. But it's also going to be a function of geometry. Right? It turns out primarily it depends on how large these conductors are. The amount of charge that we can get on those conductors depends directly on the surface area. Also depends a lot on the distance between these, and again I'll make another video talking about the geometric dependence of this, but for now I want to talk about the quantity called capacitance. Right? Capacitance is defined as charge per unit voltage. So it would have units of coulombs per volt. And the capacitance of a system is perfectly named. It's describing how much charge you can get on this system for every volt potential difference you put across it. Like most things in physics, the coulomb per volt has its own little pet name. 1 coulomb per volt is called 1 farad. Now, there's also a symbol for a capacitor. The capacitance of the system is typically represented with this symbol right here, 2 parallel lines. And now we can draw a circuit diagram for this picture. So the circuit diagram with this battery hooked up might look something like this. Right, remember, we have this symbol for the voltage of the battery, and then we would have this symbol for the capacitor. Oops, I guess I don't need that little piece right there. Right, so in my picture, This is the positive terminal. This is the negative terminal. My capacitor then would be charged plus Q on the left side minus Q on the right. And again, then we would say that the capacitor has a charge Q. And as far as how would we calculate it, we would calculate it by taking the capacitance of the system times the voltage across it. I'm just going to put V for voltage. In this example, that would be the voltage of the battery. The capacitance of the system is a geometric property. Mainly it depends on area. When the capacitors are very large, like if we have more surface area, there's just more room to put charge on. But it also depends on distance and the shape of the capacitors and such. So, and again, I'll make other videos talking about how to calculate capacitance. But for now, capacitance as a property, this is how it's defined. Charge per unit voltage. Right? So it has units of Coulomb per volt. This is its symbol in circuit diagrams. And then we have actual little devices called capacitors. And I'll show you, if you're in my physics class, you'll see some capacitors in lab. They typically look like this. They're little barrel-looking things. However, we represent them like a pair of little parallel plates in a circuit diagram. And the role of a capacitor is basically to temporarily store charge and potential energy. And they have various roles in circuits, but that's what they do. They store charge and potential energy. So I hope this video give you a reasonable idea of what a capacitor is, or what capacitance as a property is. And I'll be making more videos on calculating capacitance and going through examples of capacitors and batteries and such. So have a great day.